Hi, welcome back. We're going to continue looking at radical equations. This time we're going to be dealing with fractional exponents. First off, let's review some properties of exponents that'll help us solve these equations that involve them. So the first property we're going to look at is how to convert between a radical and a fractional exponent. So here we have the nth root of a to the m. So the root that's applied here is the nth root, and then this a is being raised to the power of m. We can write that as a fractional exponent with the power on a in the numerator and the root in the denominator. So for example, if we had the fourth root of x to the fifth power, we can write this as x raised to the fifth power, so 5, over 4 power. So radical, fractional exponent. When you're dealing with radical equations and you see a radical, you can always write it as a fractional exponent. And if you have a fractional exponent, you can always write it as a radical. So I guess the ideal state to be in would be to look at one, right, and know immediately it could be written as the other. And just be fluent with the two different forms of the same expression. Okay. So if we had an equation that involved something like this, right, we'd want to get x by itself, which means we'd have to get rid of this 5/4 power somehow. Right? And this second property will help us do that. So if we have a to the m raised to the n, so we're taking this expression a to the m and we're raising it to the nth power, we can evaluate that by simply multiplying the exponents. So a to the m times n. So, for example, if we had this x to the 5/4 and some other expression on the other side, to isolate the x, we need to raise both sides by something that when multiplied by 5/4 would give us 1. Right? And you might see that that's the reciprocal of 5/4, so 4/5, because 5/4 times 4/5 is 1. Right? So we're going to use both of these. Well, in these examples, we just have fractional exponents. We'll be mainly using this one. But like in the previous video where we had radicals, if you like the fractional exponent more, you can always write it like this. Okay. Let's look at the first example. So we have z to the 2/3 minus 4/9 equals 0. Okay, the first thing that jumps out to me in this is that we have z to the 2/3 power. Now that tells me that we have a radical equation. Right? Because remember, that denominator in the exponent, the 3 here, corresponds to a cube root. Right? So we can think of this thing as the cube root, I'll write that just over here. So we're just thinking about this as the cube root of z squared minus 4/9 equals 0. Okay, and so we want to treat it just like the radical equations we did earlier. Isolate this radical term, and then raise both sides by the appropriate power. Okay, in this case we just need to add 4/9. So we have z to the 2/3 equals plus, and add that to both sides. So 4/9, positive 4/9. All right, now we need to raise both sides by some power that cancels out this 2/3. So we need some number that when multiplied by 2/3 gives us 1. That's the reciprocal. So raise both sides to the 3/2 power. Z to the 2/3 times 3/2 is 1, so is the exponent of 1, z to the first. And then over here we have the cube root, 4/9 raised to the 3rd power, and then this 2 here is a square root. So we can think about this as 4/9 raised to the, well, actually, let me adjust that just a little bit. We can consider another property. Notice that if we take a to the m to the n equals a to the m times n, we can then, since multiplication commutes, write it as a to the n times m, and then go ahead and write this as a to the n raised to the m. So you can always swap, if you're raising something to a power, you can swap the exponents. And that's what we want to kind of look at here. We could write this as the cube root, or the square root of this thing 4/9 to the third power, or we can write it as the square root of 9/4 raised to the third power, like this. So square root of 4/9, that raised to the third power. So I guess another way we could write this is the nth root of a raised to the nth power. Sometimes it's more advantageous to take the root first and then the power second, as it will here, because we notice both 4 and 9 are squares. So the square root of 4/9 is 2/3, so z equals 2/3. I'll raise that to the third power. 2 to the third power is 8. 3 to the third power is 27. So we have z equals 8/27. All right. We always want to check our work, so we can check this. We're going to have our so check that. We've got z to the, so 8/27 to the 2/3 power minus 4/3 equals 0. Well, we take the cube root first. We get 2/3 squared minus 4/9. This thing squared is 4/9 minus 4/9 is indeed 0. So that works. So our solution, z equals 8/27. All right, let's look at the next one. So here we have 2/3 and a 1/3 as exponents. The question is, well, what power would we need to raise both sides to? And we're going to raise both sides to the third power. And we do that because if we were to raise it to the 3/2 power, we would get rid of this exponent, but we would introduce one over here. Because 3/2 times 1/3 is 1/2. So we would be introducing a radical on the right-hand side. We don't want to do that. So let's raise both sides to the third power. That gets rid of the denominators. So we have 2x minus 1. Here we raise it to the second power. And then this is just x. So we'll raise this to whatever power we need to get rid of the denominator. And we can handle a square, right? And just multiply that out. So we have 4x squared. We have minus 4x plus 1 equals x. Subtract the x. We have 4x squared minus 5x plus 1 equals 0. And now we need to factor this. So we need our 4x and our x, minus 1, minus 1. I believe that works. So 4, negative 5, plus 1, plus 4x squared. Okay. So we have x equals 1/4. And x equals 1. All right, and we of course want to check each of these answers, so we'll put in 1/4 here. So we have 2 times 1/4 is 1/2 minus 1 raised to the 2/3 power. The right-hand side we have 1/4 raised to the 1/3 power. Here we have negative 1/2 raised to the 2/3 power equals 1/4 raised to the 1/3. And we can apply the square. So this numerator, right, is the power. So we can square both sides. We have 1/4 raised to the 1/3 power equals 1/4 raised to the 1/3 power. All right, those are equal. So x equals 1/4 is part of the solution set. 1 is easier to evaluate, so we have 2x minus 1. So 2 minus 1 is 1. So we have 1 to the 2/3 power equals 1 to the 1/3 power. That's true. So both of these are our solution sets, or these are our solutions to this equation. All right, so we can now handle radical equations with radicals or fractional exponents. And that wraps up Chapter 2.